I'm Colin Walls, and I'm here once again to talk about embedded software. Today what I want to discuss is an aspect of real-time operating systems. Now, an RTOS is used in most modern embedded applications, and therefore it's important that we understand the parameters of selecting that RTOS and looking at how it's behaving. What I want to look at today is the measurement of scheduling latency. Now, latency means a delay, and since in a real-time operating system time is what it's all about, a delay is important. So we need to understand what latencies are all about. In a previous video, I've talked about measuring interrupt latency, so the delay between an interrupt being asserted and the code being executed. But today I want to look at scheduler latency, which is delays in the scheduler. In other words, the performance of the scheduler within a real-time operating system. This is obviously critical because in any embedded application, the RTOS is ultimately an overhead, and therefore the performance of the scheduler is very important because it minimizes that overhead. Now, to measure this, we need to understand what scheduling latency is. And the first starting point is to appreciate that there are two separate scenarios. Now, with some operating systems, the system can be in an idle state. In other words, it's not running any task at all. Now, in this case, if an event occurs, which means that a task needs to be scheduled, the latency would be simply the scheduler figuring out which task to run and setting it going. Now, not all real-time operating systems have an idle state. Some of them will simply run another task when they have nothing better to do. But if they do have an idle state, this is a very specific situation. The alternative is much simpler in concept in that the processor is busily running one task, an external event occurs, and it is determined that a different task needs to run, so the scheduling latency is the period of time between one task being stopped running and the other one starting. So that's the key things about scheduling latency, is there are two possible measurements, and you need to know which one somebody might be talking about. Now, if you look at these numbers on the data sheets from real-time operating system vendors, you'll see some numbers, and those numbers may well be useful, but you need to know a lot about the way they were measured. There's a whole bunch of things that you need to make sure are consistent. For example, you need to know what platform the code was executing on, what interrupt control was in use for that matter. You need to know the clock speed, the cache configuration, if there was a timer, what frequency, because that will affect the performance of the RTOS as a whole. What kind of memory was the operating system running out of? If it's running out of RAM, it'll be a lot faster than if it's running out of read-only memory. And lastly, when the kernel was built, what kind of optimization was used? Again, that will affect performance. So all these parameters must be consistent for you to be able to compare numbers between one operating system and another, or between one measurement and another. At the end of the day, it's probably best for you to make your own measurements. You can read them on a data sheet, but really understanding what that means is more difficult. To make a measurement, you basically need a spare GPIO port on the device somewhere, and you set a pin in one place where the interrupt is occurring, which results in a task swap being necessary. And you then set another pin in the location where the new task is started to deal with whatever the event was. You display those two pins on an oscilloscope, and the horizontal difference between the two spikes is the latency. You measure it literally by looking at the scale on the screen. Oscilloscopes are very interesting instruments. They're a very good way of measuring time intervals. If you're a software engineer and you have no idea about oscilloscopes, this is a really good time for getting together with your hardware counterparts who will understand them fully, and I'm sure will be very motivated to help you. So hopefully that's some useful guidance in this area of using real-time operating systems. And that's it for today, and until next time I'll say bye for now.